Hey, what's going on, y'all? Welcome to Weld.com. I may look like an unfamiliar face, and it's because I am. My name's Garrett. I'm known by the Weld.com on Instagram and TikTok. And with that being said, welcome to part one of a 4-part series where we are going to cover puddle recognition, or as I like to call it, secrets of the puddle. We're going to cover everything from TIG, stick, MIG, and flux core. Today we're covering TIG, and without further ado, let's get down to business. The equipment we're going to be using today for the TIG processes is going to be the HTP InverTIG 221 AC/DC. It's a great inverter, and it's capable of doing anything up to 220 amps. The material that we're going to be using today, starting from right to left, is you got your standard carbon A36 12 gauge. I'm going to be showing you what a puddle looks like when you're welding on dirty material. You've got 3/16 to a 1/4 inch plate. We're going to run some fillets. Over here, you've got 12 gauge A36 carbon steel, or roughly 1/8 of an inch. And then we're also going to do some stainless. This is 3/8 plate. We're going to do T-plates. We may run some weaves on it. And then we've got 12 gauge or 1/8 inch stainless as well. So we're going to cover a broad spectrum on the DC side of TIG. That way you can get a clear understanding of different types of puddle recognition and what you can expect to see. All right, y'all. So as you can see here, based off of my puddle, I'm running way too cold. This is on the 12 gauge. I'm running 70 amps, 332 filler. And you can tell by watching closely that the base metal is not being consumed into the puddle. I'm really having to stop and pause and wait for the metal to be consumed. It's not wanting to flow. I'm having a hard time feeding wire into it. It's a telltale sign, 10 times out of 10, that you're way too cold. You need to crank that up about 10 amps and see what happens from there. And here you can tell my puddle's hot. It's dancing around like crazy. It's pulling trash into the weld. Right here, I'm running 150 amps with 332 filler just to simulate what it looks like when your puddle's too hot. See how it's chasing? I can't keep up with it. It's wanting to undercut on the top. Those are the things you need to be paying attention to as you're welding. Simple adjustment, go down 10 amps, see what happens. So here I've reacted accordingly based on what my puddle's telling me to do, right? We found out it's too cold, found out it's too hot. I've turned it down. I'm running 120 amps on this same 12 gauge, and it looks better. You can tell right away that the puddle's not wandering. I'm able to control it. I'm getting good base metal fusion. I'm able to feed my wire, but I'm noticing that I'm pulling a lot of trash into the weld. That's because this particular piece I did not clean, to show you what happens even when your amperage is right, travel speed's right, but you're not properly cleaning your material, the result that is going to happen. Okay, so now that we've eliminated the dirty material and we've made it clean and we know the proper amperage that we should be at, right away you can tell puddle's clean, good ample amount of fusion with base metal. I'm able to control it. I'm able to move at a good pace. Again, we're running 120 amps. This is what you want. Okay, so y'all just saw the arc shots of what was going on, showing how a puddle was too cold, too hot, ideal, and dirty material. Now I'm going to show you the results of that, what you were seeing. You can see here, I'm going to zoom in. This was the dirty material. You can see all the oxides and mill scale that's being pulled in. And you can see every bit of that in your puddle if you're paying attention. That's why it's important to keep your material clean at all times. And here we have when my puddle was too hot. When I was running too much of amperage, you can see it's starting to pull some silica and mill scale into the weld and fighting undercut, and I was having to move at a faster pace because my puddle was too hot. You can see the undercut on the top side there. Flipping around to this side, this is where the weld puddle was too cold. I was really having to fight to get it to melt into the metal, and there was a significant void present. And it just looks choppy, looks sloppy, and that is not what you want. And your puddle will tell you every bit of that. This one here, we're going to keep it short and sweet. It's more of an ideal puddle. It's more of an ideal weld. You can tell by looking at the art footage that it was flowing freely. I didn't have to fight to manipulate the metal. It's nice and tight in. Penetration's good. It's a little cooked from doing welding on the back side, but no undercut. It tells me that that is the right amperage range that I should be at.
What's going on, everyone? Austin Hargett here, aka Dr. Welds. I'm doing a product spotlight for Weld.com on Meridian Labs rotary grounds. These things are robust industrial design made for long-lasting performance. They provide low stable resistance for high current applications. We're going to put it through the ringer today on this rollout machine. I'm going to heliarc this pipe all the way out, root to cap. Let's get to it. These grounds are super durable, super robust. They've been tested as far as how many times it can spin. Over 500 million times that thing can spin and still not have any effects. It also has been tested with lightning strikes up to 100,000 amps. So this thing can handle anything that you throw at it. It can spin as many times as you want it. It's gonna outwork you just like it's outworking me today. So we're gonna put a lid on it and finish this thing up. Long-lasting performance, unaffected by number of revolutions and the speed in which the pipe rolls. This thing's gonna outwork you every time. Use these for rotary welding, electroplating, cable reels, electro polishing, plasma cutting. It's got a lot of applications. Don't forget to check out Weld.com, sign up for the app. Don't forget to like, subscribe, and follow. Till next time.
What I'm going to do now is I want to dive into walking the cup. Not necessarily the technique, but it will be easier for me to demonstrate and give you a different lens, if you will, on exactly what's going on. And I want to touch specifically on arc force, torch angle, and travel speed, and how even being at the same amperage, by changing those three things, how it affects your puddle, your heat affected zone, and everything else. So as you'll see, I've got a little setup that I've MacGyvered together here, and I think I'm living proof that you don't have to do anything fancy to learn something new. So with that being said, what I'm going to be using is a CK17 flex head with, I've switched from the glass lens that I was using earlier, and that was solely for arc shots and content. It's not needed, but I've switched to the same style, but it is the BBW from Furic. And that's what I like to use when I'm under 180 amps and I'm walking the cup. I want to show you, before we drop our hood and get down to business, what I'm talking about with torch angle and how it can affect things. So, as you can see here, I like to maintain a 30 to 45 degree pitch. And the reason for that is it allows me to move at a steady pace and not let my material heat up too much. I'm going to show you the exact same thing if I shorten my stick out, how it directly affects my torch angle. So you can see I've changed my stick out, which in turn is going to increase the amount of movement I have to have, and therefore it's going to be inputting more heat into my workpiece with the same amperage because I'm staying in one place longer. Does that make sense? Now I'm going to extend it further drastically just to paint a better picture of what I'm saying. Now, I've drastically extended this just for demonstration purposes. I do not recommend this. Actually, I do not recommend extending your tungsten any further than the diameter of your cup. But with that being said, for demonstration purposes only, to show travel speed and how tungsten stick out affects your torch angle, okay? Look how much more area I'm covering with the same movement. All right, I just wanted to touch on that so you can kind of get a better understanding of what I'm talking about when I'm showing you behind my lens. And with that being said, let's drop the hood and get to it. All right, y'all. So this is the finished result of the clips you just saw under the hood. And I just want to show you the distinct change in amperage, your weld puddle, what the weld looks like, your heat affected zone, your oxidation rate, everything. So the torch angle was the same. Every travel speed might have changed a little bit to try and keep up with the puddle as the heat increased. But I want to show you in steps the effect that amperage has on your overall outcome. Okay? So here we have, and this is on 3/8 plate running slightly uphill. We have 332, 316 filler running at 90 amps. You can see it's real choppy. The movement was slower. It wasn't fusing with the base metal. It wasn't being consumed. And then we step it up to 120 amps. You could tell that from side to side it was flowing a little better. And this is what I want you to go back and look at the art footage and really try and digest what I'm saying here. So at 120 amps, it started flowing a little better. We were able to move a little faster, but the base metal still wasn't being consumed the way that it should be to make a sound and quality weld. Middle of the pack here is where I think is ideal for this situation based on my travel speed, my tungsten stick out, and my technique, along with my rate of filler. Okay? You could tell it was flowing. It was running the way it should. It looked free. It looked like I could manipulate it and do whatever I wanted to do with that weld, with the puddle at the time. It's uniform. Oxidation rate was very good before I continued to run out. But you can just tell out of the 5, it's the best weld. Going further, I stepped it up to 170 amps, running same filler, same everything. The puddle started getting erratic. It was hard. So what I mean by that is in the side-to-side transfer, as the weld solidified, so you'll watch it cool and then chase back, cool and then chase back. It was very quick and it was shaky, right? That's telling me that I'm getting too hot. It's still an okay weld. It's probably out of the 5, it's the second best, but you're pushing the envelope on what the metal can take. Moving forward, I stepped it up to 200 amps, and you can tell right away, especially when you're watching the art footage, the puddle is uncontrollable. The heat affected zone is insane. The oxidation rate, it's gray. It's no bueno whatsoever. So I just wanted to show from the bottom of the spectrum to the top and kind of give you a step-by-step in increase to see what a difference 90 amps is versus 200. All right, y'all. So as you're about to see, we're rocking 3/8 stainless steel 304 plate, running a T-joint here. And I'm starting out with 332 tungsten, 332 filler, and I'm running 25 to 30 CFH at 130 amps. And you can see as we're going through here, my travel speed's very slow. It's taking a long time for the base metal to heat up enough to be sufficient enough and create the right environment for me to add filler and create a good weld. I don't have enough amperage. I don't have enough heat. I don't have enough arc force. I don't have enough of all the good stuff to make the business happen and to make a good weld. Moving forward here, the only parameters that's going to change is I bumped it up from 130 to 150 because I knew that everything was too slow. Nothing was flowing. And I can tell immediately that my base metal is being consumed, not creating undercut. I'm able to feed wire and maintain a steady pace and not have to wait. It's free flowing. It's moving the way it should as far as the puddle is concerned. And that lets me know that I'm right in the ballpark of where I need to be. And then from here, we're going to step it up to 180 amps just to show what too hot or borderline too hot of a puddle on a fillet weld and a T-joint like this looks like. I'm having to really feed the wire in and I'm chasing my puddle. So it's trying to run away from me and I'm really having to work to keep it consistent and steady. It's too hot. You'll notice here as we look at the differences between the 3 amperage range, how the weld gets bigger, right? So at 180, I'm having to step further apart. I'm getting slight undercut on the top end and I'm having to feed more wire. And the heat affected zone is growing. As we step down to 150 amps, you can see it's more ideal for this thickness of material. Everything's nice and tidy. It flowed in the arc shots. I was able to move at a steady rate, and 130 amps, it doesn't look bad, right? But I had to spend way too much time making that puddle consume in order to add filler. And when I was adding filler, it wasn't wanting to consume it and take it all in. It wasn't natural. I was having to force it. It's crazy how much a difference 20 amps and 30 amps can make. All right, coming back in for the second pass, using the same amperage respectively, we're going to use a lay wire technique instead of the dip like we did before. And again, you'll notice a trend here, right? My amperage is sufficient enough to melt everything together to make that perfect marriage that we're wanting, but my travel speed's slow. I'm having to really wait and concentrate and tie in the sides. And that tells me, again, that I should probably turn it up a little bit because I'm not getting the most out of my filler and my torch. Now stepping it up to 150 on the second pass using the lay wire technique. I truly feel like this is the sweet spot for this thickness of material. You'll notice the puddle's chasing me, but it's not uncontrollable. My travel speed is able to move up. This is all shot in real time. I'm able to achieve the same weld that I was earlier, but I can do it much more efficiently and without having to fight what I'm doing. At the end of the day, we got to keep it simple, y'all. That it's not rocket science, okay? Simplify it to the point to where everything works as it should work. If you're fighting it, something's wrong. Again, stepping it up to 180 here. I'm using the same technique, same arc length, same everything. You'll notice if you watch the edge of the weld, that puddle's really starting to bounce back and forth. And then I had to stop, regather myself, and grab a new piece of wire. But you'll notice if you watch the edges of the weld, I'm really having to move faster, and I'm having to apply more filler, more wire into the puddle, if you will, to make sure that that puddle is happy, right? To avoid undercut, to avoid it getting really out of control. See, you can see it. Look at the back of the puddle. You see it really dancing back and forth. It's erratic. It's not smooth. You'll hear me use erratic a lot when you're talking about being too hot, but there's a reason for that. You can see it when you're looking at the puddle. That's when you know you're getting on the outer realm of where you should be. Okay, so moving forward, this is the same amperage ranges on the exact same thickness of material, exact same parameters, settings, everything. I'm just showing you a different angle, right? So I will start on 180 amps this time. You can see it heats up quickly. I'm having to really press down and keep that force of the filler going in. And I'm having to move quickly to keep the puddle sufficed. Same thing again, we're going to step it down to 150. Notice immediately how the base metal is consumed. And this is what I mean by flow. It's flowing nice. I'm able to manipulate the weld how I see fit. And I'm able to push as much filler in as I want. And it will still be a quality weld. That's when you know you're in the sweet spot. And now here, finally, we're going to step it down to 130. Definitely the cooler end of the spectrum as far as this material is considered. And you'll see it's after going from high to low, right? You'll see I'm having to move much slower. I'm really having to wait, let it pause on the sides, let it consume in the middle. That's because I'm probably too cold for this application. In a pinch, it'll work, but it's not ideal. These are the differences and the details that you need to be focusing on. And there you have it, y'all. We went in depth and covered many of the things that you can expect to see and how to fix it. I hope you'll join me for part 2, where we're going to dive into stick, and that's a whole nother animal entirely, and I'm excited to share it with you. Something that I like to do, and I will do with every video that I do, is leave you with an inspirational quote. And it goes like this, right? Success to anything is in the details, in my opinion. And when it comes to welding, success or failure is in the puddle. So remember that, and make sure that you stay up to date and in tune with Weld.com app, because it will only be available here. And I look forward to seeing you in part 2. Till then, God bless.